All right, I'm back. So last part we finished the analog board. Right now, let's see what's next. So the next thing is pin header, the capacitor, switches, blah blah blah. Okay. So apparently this pin header, right? It says J1 and J6, which is this and this over here. So this is where the BNC is supposed to go. So okay, I get it now. So it's either you install one of these or one of these. So with this header, you could just connect any 2-pin JST plug here like that, and then you can connect your makeshift probe or something to measure a signal. I think I'll leave this empty for now because, well, maybe I can make a custom cable. So my end goal is to have maybe I'll make like a JST, one side JST and the other is like a 3.5 millimeter plug, so I can plug into my synth and then measure the signals like that. So I think I'm gonna leave this. Well, I mean, I could solder this on right now, but anyway, I'm gonna do this J6 first. Apparently this one is battery. Maybe like this. Let me double check. It doesn't say. Let me see on this board. So, oh, okay, so the orientation is like this in the final form. It looks kind of dumb if you put it that way, right? But it looks okay if you put it like that. Oh, maybe you can put the battery here or something. But I don't need the battery right now, right? I mean, I'm just gonna power this using USB power or something. I think I'll leave this. These pin headers, these JST plugs for now. Yeah. So what's next? Okay, next is the electrolytic capacitors. So they are these, and these are all 100 micro. That's right. So the thing with these are, see, there's like two legs. So these have, the polarity matters. Usually the longer leg is positive, and it is also indicated by this stripe here. See, the other one doesn't have stripe, that's positive, and the one that has stripe, see, it has like a negative sign over here, so that's negative. And on the board you would see like, oh yeah, there's a positive, so the longer end goes into the positive. So 10, 11, 12, 13, 14 are all these electrolytic cap. We could, and they're the same value too. I'm just gonna make sure 100 micro, 100 micro, 100 micro, 100, just to be sure, 100 and 100. Okay, they're all good. So we can just put them all in at once and then solder them together. So the longer leg goes to positive, longer leg positive, longer leg positive, same thing here, same thing here. Alright, now it's all in there. I'm just gonna plop it down here. So this thing really wiggles. Okay. Okay, they're all like straight up right now. So I'm just going to solder them one pin at one leg at a time, and then we can adjust if it's crooked or not. Okay. Alright. So like it's all sort of tilted that way. What I'm gonna do is I'm just gonna press it down here and then reflow this pin while I'm giving it pressure, so that way it like flows into place. This one really has no problem. You hear that click, that means it's hitting the board. Okay, so right now that looks perfect. Now let's solder the rest of the other pins on. Okay. Okay. Now let's just cut these legs. I think I will, since the solder contains flux, which means it will leave like a residue on the board. So I'm not sure if you can see that, but like, see where all the, near the pads, there's like this blob of gunk. Those are flux that's in, you know, in the middle of the solder. So these are like rosin core, I think. But we're gonna clean that out later. So what's next? Slide switches. I think these are fairly self-explanatory because it also has polarity, but look, like one of the leg is to the side, so you can easily just put it down there like so. So these holes, you can just put it down like this. Oh, they also kind of has a friction, so it doesn't fall out. That's good. That's perfect. Put this thing down. Put this one down. And this final one, I think this goes here. Yep, this is the power switch. Okay. Perfect. Alright. It's a lot of pins, but we can do this. Okay. They're kind of close together, but it's fine. Okay. Sometimes I put like, when, you know, the side is higher, I put something, in this case is my plier or my cutter to support the other side. I should really get a vise. That's on my list now. Oh God. Okay, that's done. Okay. Great. Great. Maybe we should face it like so. Yeah, it's better. Reflow them a little bit. Alright. Okay. Next up, over here. Awesome. Awesome. Great. Alright, so one of the trick is to heat up both the pad and your component. And then just touch your solder briefly, it'll flow itself to the holes. Perfect. And these are especially good because they're like one-sided like so. So you can like get to the board really precise in an angle. Before I used to have the pointy tip ones. I thought they're good because like the ends are so pointy and I can get to the parts. Oh, I forgot this. I can get to the parts really precisely. But turns out that's not the best solution. Like, what's better is to have something like this, so you can touch both component, both the pad and the legs or SMDs at the same time. Okay, all right, let me see, inspect the spin a bit. Oh, we forgot 2 legs on this switch. No big deal. Perfect. Let me see what needs to be soldered. So I usually like to leave these ground pins for later, because those are so hard to get off once you solder them. Like if something went wrong, like maybe the component broke, or maybe you soldered the wrong component. Things like pots have such big mechanical stand or support that goes on the board, and those are really hard to get off once you have it soldered. So I'm just gonna leave it until after I fully assemble this and test it out. So it looks good now. All right, what's next? The pin header. So there's total of what? 3 10 pin, 1 by 3 pin, and then 2 pin. So J5 is this guy, so it says to go like that. My guess is this goes to the display board, or the main board. So let's just do it one by one. So the trick with these headers is I would just solder like one pin and then left it like that, and then you can, so like right now you can see if you get it straight or not, and if not, usually there you don't. So you just, again, like pressing here, and you can, after you're heating up this pin, you can slightly adjust it with your index finger, and you can like feel the pin getting flush on the board like that. See, that's perfect. And now we're just gonna go through every other pin now. Easy peasy. Great. As long as it's not a cold joint, then it's good. You can usually tell if it's a cold joint by the way the solder looks after you solder them on. So if it looks like a little circle like that, then it's bad. But if it looks like this, like a pointy mountain, then that's perfect. All right. Now the 3-pin one, J2. J2 is over here. Not sure what that does, but we'll find out. Looks like it's some external power, maybe. So these are sort of hard to get it straight because there's only so much surface. You might have to adjust it several times, but we got it. All right. Perfect. So now we have this 2-pin J3. Where is J3? J3 is over here. Not sure what that do, but we'll find out. It says signal and ground. Oh, we got it relatively close. Okay. Perfect 90-degree to the board. This one is the ground. Ground usually takes longer because of the ground plane it got there. Great. This is looking really good so far. I like it. Right now on the switch. So the switch goes like this. This is fairly easy because the switches itself kind of latch onto the board once you install it, so you don't have to worry too much about it being all wiggly. Okay. I think I will wipe the board with alcohol later, so nothing wonky will go on with the joint. Alright, so fairly simple. Plop it down. Okay, now just solder them all at once. Again, the trick to not get short joint. Well, the first trick, actually, I mean, the most important thing is get yourself a good iron, because a bad iron won't conduct heat that good, and you will have cold joints all the time, and it's really hard to debug. Because how are you gonna know if that's a dodgy connection or not? Because sometimes it does have connection, and sometimes maybe like high impedance connection, and stuff works sometimes it does not. So, and the other trick is to leave your tip on the component for a while for it to like fully merge together, if you know what I mean. Alright, so this part is done. What's next? Jumpers. Short JP2 and JP3 with solder. Keep JP4, 5, 6 open. JP1 has been pre-shorted. So 2 and 3. So I think what they mean is this JP3, JP2. That's weird because if they short JP1 has been pre-soldered. Oh yeah. Oh, okay, so they've shorted it in the circuit already for JP1, and they just want us to short these two. Okay, it's fairly simple. So just like that. There we go. That's shorted. If that does not, clean your tip and then try again. It shouldn't be that hard to short these two stuff. Is that shorted? No. Sometimes you need a lot of solder for it to short for some reason. Come on. Okay, oh god, I got it. Okay, great. Wait, did I short the other pin, the other connection? It's kind of dodgy. I want to short that in a better way. Okay, great. So let's try this. Let's try something. I'm not sure if I can do this. You just bring it up like so. Okay. Yeah. Alright, so you guys see those are shorted. I get to see that's shorted too. Okay, so let's flip to the other side of this thing. Oh, looks like we're done. That's crazy. Wait, okay, so okay, so we have the other part. Okay, so I guess the finished product goes like, oh no, so it's, well, let me see. So it's like this. Oh, okay, I see what's going on. So there are these female headers. I guess they just go like this, like this. Okay, so the trick is to just put them all on. You know, just put them all on the male header, and then you can plop this down. It makes it so much easier to solder like that. See, like all the pins stands up nicely and 90 degree, which is perfect. And now we just solder them on. But still, I would just solder one side first. Like one pin, I mean. And then I would take it. Oh, what? That's funny. It came off like so, like this. That's fine. We can just plug it back in. Because I want to make sure, like, they're really 90 degree, you know? See, like, this one's slightly, all of them are slightly tilted this way. So I'll just slightly adjust it. They're fine. Now we can just go ahead and solder stuff on there. Ooh, a lot of smoke coming out. I actually have a fume extractor, but God, that smells so bad. If I turn that on, it's gonna be too loud. The fume extractor is basically just a fan that sucks air out the other way. So you know these smoky stuff doesn't, you don't breathe it in. Okay, perfect. Now what? Let's see. Okay, so now you're supposed to make this. So there's two cables. One of them is longer than the other. I guess this longer one could be, whoa, that's really long. This longer one could be our makeshift probe. What I want, oh, it's so curly, cool. What I want is I want to, you know, kind of like braid it a little bit. But it's too curly now. It's so funny. I'm gonna deal with this curly situation later. So what we're gonna do is basically we're just going to solder it on our, remember when you're doing this thing you have to make sure to get it there first, so you know you don't solder this and you realize, oh, I have no way to put the caps back in. So this thing just goes in like that and like this. There's a hole on this probe, not sure if you can see, but yeah, just gonna solder this directly. I need to stick it on the metallic piece a little bit longer so the solder merges with the metal. see what I can do to get this thing easier. Okay, great. Perfect. That looks good. That looks good. And then we can cut this piece out. So how this works is then you can plug this back in like so. And now you have this, your makeshift header. Cool. I like these a lot because they stick on your subjects really good. I want to bend this thing a bit so this can be plugged here, and when we stuff it in like this, and then we just solder that. Yeah. Okay, cool. Oh shit, see, I forgot. I forgot to put in that red cap. So now I have to pull that apart. And now I don't have the holes anymore, so I have to solder socket. Great. Okay. Alright. Ooh, it's hot. Just burned myself a bit. No worries. Okay, let's put this back. Great. Our thing works. Awesome. So let me see. How do we? Okay, you know, I think we still need this thing, but I'm not gonna use this BNC connector right now, simply because I don't have a probe, and I already make that makeshift probe. So I'm just gonna peel this thing, this tape here. Neighbor's dog. Come on. Alright. Come on. Alright. It's a Captain tape. And then I'm just gonna solder on this header guy. Nice. Ooh, that fell out real quick. Alright, so super trick shot. What you do is you wound this thing like that, because I'm holding it like that, one hand, and the other hand I'm just going to do it like this. Alright, so it's perfectly aligned. If not, we can just go ahead and fix it. That looks great. And then we can solder on the other side. Reflow the other side. Okay. Great. Okay, let's put this together. I like how it's, you know, like at the corners. Wow, that looks really good. Awesome. Let's just turn it on. Oh, wait, we better read this manual, right? Attention, power supply voltage must not exceed 8 volt. Allowed maximum signal input voltage is 50 volt peak to peak. Okay. Okay, cool. No, VPK, which is 100 VPP. So I don't know what the K stands for, but it's like, so if you have a wave, like a sine wave, and it goes from -50 to +50, then that's, you know, the difference is 100. So that's peak to peak 100. So that's the maximum it has on this scope. So how do we calibrate this? Don't they have something? Test signal ring. Make a small ring with a lead cutoff. Solder the ring to the J4. Why? Why do I have to do that? Oh, I see what that is now. So, oh, okay. So I completely forgot this. So what you do is all the scope, they have this ring like this, and it acts. It just has a square wave signal for like calibrations and whatnot. Oh, this is gonna be really hard to solder, but we're gonna be fine. So what I'm gonna do is this, lower it down a little. I'm just going to get one side first. So, come on. Is that great? No, that's actually, we actually nailed it pretty much. Yeah, that's perfect. So the Rio scope also have this thing. It is used for calibration. So it's constantly outputting a square wave signal. So now what we can do, we can just hook this thing up like that, and then we can hook this to like some ground, and then we can see that square wave up here, so we can calibrate it. You know, there are things we can adjust, like this pot here, or the trim capacitor. Okay, so it says insert hook probe to J1. So like this. The red hook to the signal test terminal, so like this. So now black probe. Set SEM1 switch to 0.1 volt. Oh, cool. So it has 0.1, so in the middle. So these are like send 1, send 2. Okay, so my guess is this is I forgot what that's called. Volt per division or something. And this is like if you want to multiply the signal by X factor, which is 1, 2, and 5. So it tells us to set this to here. Okay. The send 2 switch to X5, so all the way down here. Set CPL to AC or DC, so it doesn't matter as long as AC or DC. It has, so this is like coupling, so DC coupling, AC coupling, or ground. So either DC or AC will work fine. Okay, adjust the time base 0.2 microsecond. What? Oh, so I don't need this negative. I guess it's internally grounded or something. So let's power it up and see if it works. I'm so excited now. Okay. Alright, let's hope there's no blue smoke for the magic smoke coming out. Let's make sure nothing is gonna short it. Let's disconnect it first. Okay. Oh, look at that. Okay, let's plug this here. Whoa, check it out, it works. So what does it say? Time base to 0.2 millisecond. So I guess it's this. Oh, okay. 0.2 millisecond. Okay. Oh, because we're using DC coupling, that's why it's offsetting, you know, that way. So if we switch to AC, then it drops down because, so this might be an AC signal. Okay, so anyway, let's see. I just see the 0.2 city waveform similar to the shown in the photo. If traces are not stable, just adjust the trigger level, the pink triangle on the right screen, so you get the display. How do I adjust the trigger? Okay, let's do this. Turn C4 with a small screwdriver so that the waveform display shows photo C. Oh, I see. Oh, okay. So it's saying what's saying is, the edges here has to be sharp. So it cannot be. So right now it's sort of cornered, like it's not square enough, or maybe over here as well. And let me just try to adjust it, see what happens. Where is my, here it is. C what? C4, which is this one up here. Oh, okay, so this is too much. This is how they say it's too much. So we want it to be like perfectly square. Okay, so that's perfectly squared. Maybe a little bit too much. Okay, that's great. Okay, set send one switch to 1 volt. Wait, what? Oh, okay, so here to 1 volt and send 2 to X1. While keep the other settings unchanged. Adjust C6 so that the sharp right angle waveform is displayed. Okay. Interesting, that doesn't do a lot of things. That does not do anything. Let's see. Send 1 is set to. Let's see if that changes anything. No. 1 volt all the way here. And to X1. I guess I'm not so sure why it's not well, I think it's changing. No, it's not. Not even slightly. Well, I'm not sure what is wrong. Let's get time base. Maybe it's like, you know, microscopic. Oh, I see. So this adjusts that. I think in this right now we are able to see it more. No. Nothing seems to be changing. But I mean, it looks pretty sharp right now already. Oh, so this one doesn't change that. I see what's going on. Hang on a little bit. Because I adjusted that. So it looks like this C6 is not doing anything. Well, let's see if there's anything obviously wrong. Like if we mis-solder or something. They all look fine to me. We could try retouching some components. Maybe we have a cold joint. Not really sure. But it looks fine, like without doing anything though. Like it says to keep the edges sharp like the others one. I guess it's pretty sharp right now. Maybe we don't have to do anything. When I like, whoa, when I wiggle this, it actually move a little. So how do I adjust the trigger? That's one of my questions. The pink triangle on right screen border. Running. Oh, that holds it. I never played with one of these. I just wanna. Oh, okay. Oh, I see how this works. So, this SEL select, basically, it has a square that just toggles, that goes around. So I think right now something up there, and then so like once you select that, you can you know change whatever value. And now it's hold now. Running. I think this is trigger, right? Let's see if this do anything. Not really. I don't see any change. Well, a little bit, but not so much. Oh, internal trigger, external trigger. Okay. What does this do? Oh, okay, so this thing, see this right arrow? This thingy here? Since we're on AC coupling, that doesn't matter. That's like offset. I think that's what it's called. So if we switch to DC, then it will move the thing, right? No, I'm wrong. I don't know what that do. I forgot. Okay. So what does this do? Oh, okay. So this is, I'm currently selecting this. It's not very obvious. Okay, so this thing turns blue. So it's just, you know, shifting it this way or that way. So I guess this is adjusting the trigger. Oh, okay. So when you have that, then you have, when you select this thing, it actually sort of blinks. Then you have this pink arrow. Then we're back here. Anyway, that looks good though, to me. I'm going to see if there's some obvious problem on the analog board and maybe clean the pins a little bit. But I think so far I'm pretty happy with this build. I mean, it really works. Look. Do we want to feed it some audio signal and just see if that works? Yeah, I think that would be cool. Let me hook up my synthesizer and see if it works. Alright, just hang on a sec. So, my synth. Just gonna put it on my chair for now, since my table is too crowded. flash cable. Alright, I'm so excited to see this thing finally working. Like fully working. And there are modules, like synthesizer modules, that is just a scope. Power. Okay. Alright, so let's see if this works. So I got my synth turned on. Gonna connect it to tides, which is this module. I have it on cyclic mode. Let's do unipolar first. So unipolar means the output is 0 to whatever. Bipolar means it could be negative signal, so like it's, you know, fully like goes both ways. Alright, so this thing outputs something like this. It's just a standard 3.5 millimeter jack, but it's mono signal. So this ring here, the sleeve, is negative or ground, and this one is positive. So what we're gonna do, well, I'm going to solder something real quick. Hang on a sec. Oh, we don't need to solder this. So I have this thing. So what's so good about this is you can just, you know, hook it like that. This is just a one of the jack. This thing goes like that. Okay, perfect. Let's get this back. Alright, moment of truth, guys. Oh, look at that. Bouncy boy. So this means it's not triggering correctly. Well, let me just adjust the frequency. Nope. Oh, look at that. Look at that. It works. And I can do this. Like the smoothness. Since this is unipolar, when I turn the smooth all the way to 0, it just becomes almost 0. Oh, but it also matters because we're using AC signal. So like if we use DC, it's going to be offset because it's only getting the DC part of the signal. But okay, let's do this. Whoa, look at that. This is the slope. This is the middle. So that's, whoa, that's pretty cool. The other way. Damn, okay. And then we have shape. It looks like it just adjusts the intensity. Kind of like smoothness. Oh, so look at that. The smoothness actually changes the shapes a little bit. So that was unipolar. Let's try bipolar. Oh yeah. So look at that. This is adjusting the smoothness. Oh, there's this freaking they even put their advertisements out down there, and it only shows up after a while. Wow. All right. Since this is open source, I'm going to take a look at their code and see if we can remove that and all that Chinese stuff. Oh, it disappeared. Slope. Cool, dude. And then the shape. So the shape doesn't really do much, I guess. I mean, in this frequency, if we adjust the frequency a bit, yeah, it actually just does that. And wow, this is really, it looks really cool. Just look at that. So when it moves, I think it's just, it can find the right trigger. This is so cool. Look at that, that's hardcore. Oh god, I'm so happy with this buy. Now I can like see whatever signal. Let's really quick patch up something. Okay, let's see. So I'm running this through a filter. Oh, the filter just totally put down the scale. Look at that. So this is the resonance. This is the frequency. So I guess the filter, what the filter does is when you adjust to a certain frequency, it just cuts off the signal. Okay, so the bad thing about this scope is it's not two channel, so I can't really compare a before and after sort of thing. So I'm adjusting the filter cutoff signal, the cutoff knob. So like so right now it's higher. Now like when it's higher than this, it's gonna cut off. So when it's lower, 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 and so now that becomes all completely cut off. But if I adjust, increase the frequency, okay, I can't increase the frequency anymore. But yeah, I guess that's how this works. That's pretty cool. I'm very happy with this result. Yeah. Awesome. Oh, you know what? There's one more thing we can do. I mean, one more thing we have to do. So let me put this away. This one thing. Oh, you know what? Maybe I'll do that later. What I wanted to say was, you know, let's put it in this case. But I want to clean the back of this analog board a little, and then I'll put it together. But, I mean, that's pretty cool. That's good enough for today. I'll clean up after and then maybe post a picture when it's finished in a case or something. So, alright, that's it. I'm very happy with this, considering it's just 20 bucks or something. Okay, well, I guess I'll see you guys next time, or tomorrow. Bye bye.